Okay, so today we're going to talk about chapter 6, which is fingerprints. In this chapter, you will explore the following: the formation of fingerprints during development, different types of fingerprint analysis, how to collect, process, and analyze fingerprint evidence, and why today fingerprint evidence may not be 100% unique as described um, or historically as has been known. So analyzing fingerprint evidence today involves far more than looking at fingerprints left at a crime scene. The technology has advanced the world of fingerprint analysis and has come a long way since taking a fingerprint card and trying to match up specific structures. Law enforcement officers can quickly submit fingerprints to a national database and potentially get a hit pretty quickly. Although fingerprints are mostly considered individual evidence, biometrics have improved the ability to establish one's identity. If we look at the overall history of fingerprinting, ancient interest in fingerprints, we had Chinese use of fingerprints and palm prints pressed into clay in the 3rd century BC. Fingerprints pressed into clay tablet contracts date back to Babylon. Ancient China inked fingerprints on official documents were common. In Western culture, in 1684, the earliest record of the study of the pattern of human hands. 1823, we had Purkinje described 9 distinct fingerprint patterns. 1856, Herschel noted that fingerprint patterns are not altered by age. And in 2014, the Next Generation Identification, or NGI, added facial recognition. So let's talk about the science of fingerprints. Look at the surface of your fingers. Are they smooth and shiny? No. All fingers, toes, feet, and palms are covered in small ridges. These are raised portions of the skin arranged in connected units called dermal or friction ridges. They help us with our grip on objects that we touch. When these ridges press against things, they leave marks. A finger leaves an impression called a fingerprint. The imprint of the fingerprint consists of natural secretions of the sweat glands that are present in the friction ridges of the skin. The secretions are a mixture mainly of water, oils, and salts. Dirt from everyday activities is also mixed in these secretions. Anytime you touch something, you'll leave behind traces of these substances in a unique pattern of your dermal ridges. Due to the uniqueness of fingerprints to an individual, this type of evidence can be considered individual evidence. So the ridges on the fingers are raised portions of the skin. They're arranged in connected units, and they leave marks when pressed against things, allowing it for, again, to be considered individual evidence. The formation of fingerprints. The patterns are formed during the 10th week of gestation. The ridge patterns are at the end pads of the fingers. They form lines on surfaces of objects. They grow in the basal layer of the cells of the skin, and they may be altered by scars with damage to the dermal layer. The individual nature of fingerprints has been known for about 2,000 years. However, scientists only recently discovered the friction ridges leading to fingerprints form in the womb. The latest information suggests that it is at the 10th week of gestation. Note that although identical twins have the same DNA, they will not actually have the same fingerprints due to alterations during gestation. The ridge patterns are the ridges found in the areas such as the pads of the fingers, and they form the lines on the surfaces of the fingerprints. The development of the ridge patterns happens in the basal layer of the skin, where new skin cells are produced. As the basal layer grows, unique ridge patterns form, influenced by the environment surrounding the fetus. The pattern can be altered by damage to the dermal layer, such as a scar. There are different types of fingerprints that can be found. At first glance, it may be difficult to distinguish one fingerprint from another, but understanding the different patterns and variations of the ridge patterns, you will be able to detect differences in fingerprints. So we have different types of fingerprints. We have patent fingerprints or visible prints, which are left on smooth surface when blood, paint, grease, ink, or some other mineral comes in contact with the hands and is transferred to that surface. Plastic fingerprints are actual indentations left in some soft material, such as clay, putty, or wax. And then finally, latent fingerprints, or prints which are not visible to the unaided eye, are caused by the transfer of oils and other bodily secretions onto the surface. They can be developed into visible prints by dusting with powders and or lifting or by using an adhesive lifter. If we look at the overall basic ridge patterns, fingerprint characteristics are named for the general visual appearance. Major ridge patterns are loops, whorls, and arches, as shown in the figure here. Arches and ridges that enter from one side of the fingerprint and leave from the other side with a rise in the center. Whorls look like a bullseye. Loops enter and exit from the same direction. The core is the center of the loop or whorl. Some fingerprints can have a triangular ridge pattern called a delta. A delta is where ridge patterns diverge or change direction. Some of the ridges go by the delta and some of the ridges go below the delta. A ridge count, which is the number of ridges between the core and the center of the delta, may help to distinguish one fingerprint from another. To take a ridge count for a loop pattern, an imaginary line is drawn from the center of the core to the middle of the delta. Count the number of ridges between the core and the center of the delta. Looking at other types of characteristics of fingerprints. While looking at the basic fingerprint patterns can quickly help to exclude a suspect, in order to consider a print found at a crime scene consistent with that of an individual, more information is needed. An examiner needs to know if he is viewing a partial print, multiple prints, or prints from a right or left hand. Every individual, including identical twins, has unique ridge characteristics detailed as minutia because the details are so small. Recognizing the minutia and their relative number and their location on specific fingerprints is called fingerprint identification. There are about 150 individual ridge characteristics on the average full fingerprint. When forensics examiners identify a fingerprint, they are, in theory, identifying the unique signature of a person. Different types of minutia patterns will include, and this is in figure 610 of your book, ridge endings, fork, or bifurcation, island ridge or short ridge, a dot, a bridge, a spur, an eye, a double bifurcation, delta, or trifurcation. Collecting and documenting fingerprints. When collecting and documenting evidence, it is important to follow the proper procedures. Because fingerprints are difficult to see, all crime scene investigators need to be specifically trained in where to look for fingerprint evidence, how to identify different types of fingerprints, what type of lighting, powders, or chemicals should be used to enhance the fingerprint, and how to photograph and document each fingerprint. When you are photographing fingerprints, because not all fingerprints are visible, it takes a trained CSI to know where to recover possible fingerprints. Crime scene investigators often use alternative light sources such as lasers or LED devices to emit particular wavelengths of light or to use filters on the light source to help identify a fingerprint. Once located, all fingerprints should be photographed. Close-up photographs, as well as photos that show where the fingerprint was found in relationship to the crime scene, should be taken. After the fingerprint is enhanced, other photos should be taken as well. All photos and fingerprint evidence are logged as actual evidence. For collecting of fingerprints, all fingerprint evidence should be documented in an evidence log. Chain of custody should be completed for each fingerprint. The method of collection differs depending on the type of fingerprints. So if we wanted to collect latent fingerprints are not easily visible, but techniques can enhance their visibility. To enhance a latent print, dusting smooth, non-porous surfaces, such as a drinking glass, the faucets of sinks, telephones, and the like, with a fine carbon powder can make fingerprint more visible. Magnetic powders may also be used and are easier to clean than dusting powders. Fluorescent dye stains or powders aided with a laser or light source can also be used. Tape is used to lift and preserve the fingerprints. Latent prints are fragile and can easily be affected by environmental factors, such as simply just wiping down a surface. Collecting of patent prints. Patent or visible prints found in blood or ink are immediately photographed. If a patent print is on the surface, such as a shirt or a piece of paper, the item is dried and then bagged in a proper bag. The blood or liquid that was found in the print could be further analyzed. Plastic prints that appear in indentations on soft items such as photographed. Soft items are photographed. They usually do not require any enhancements. The item with the plastic prints can be collected and may be casted if necessary. And then finally, collecting of suspect prints. Fingerprints of suspects are taken by rolling each of the 10 fingers in ink and then rolling them onto print cards. You can also use something like coconut oil if you're taking more digital prints, which is what's commonly used for today. Different types of methods that are used for visualizing latent fingerprints. We have a chemical called anhydride. What this will do is it reacts with the amino acids, which form proteins that's found in sweat, and it will create a bluish purplish print. Cyanoacrylates, which is oftentimes commonly referred to as crazy glue, reacts with the amino acids as well, proteins and fatty acids, and this will actually create a white print. This is for detecting latent prints for the anhydride and the cyanoacrylate. We can also do iodine fuming. Iodine, like you typically find in a drugstore, Iodine will combine with the carbohydrates in the latent prints, and this will actually create a brownish print, but it can fade quickly. So forensic analysis of fingerprinting. The initial analysis. Fingerprint analysis and fingerprint storage of data have changed dramatically since the turn of the century when individual experts analyzed, copied, and stored fingerprint on paper. Today, fingerprints are taken digitally, stored in huge computer databases, shared both nationally and internationally, and easily accessed from mobile police units. The initial and final fingerprint assessments are completed by person. However, most of the analysis are done electronically. Automated fingerprint searches. In 1999, we had IFS. In 2011, we had FBI's NGI. And in 2019, we have the database, which is referred to as RISC. Today, most fingerprints are compared using technology first, with the final comparison made by an expert. Using image enhancement algorithms, fingerprint quality and clarity can be improved and marked. Scanners are used to identify and mark minutia points. Software calculates the distance and angles between key minutia points and defines a unique pattern known as an algorithm. Instead of examining individual ridges and minutia, the computer searches for the pattern formed from the minutia and the ridges. A computer rapidly searches the databases for fingerprints and are consistent with the algorithm or unique pattern formed by the ridges and the minutia patterns. The computer search for the pattern or algorithm is not only much faster, but it can also significantly reduce the search to a smaller number of individuals. Most fingerprints recovered from a crime scene are often partial prints and often smudged. New studies show that initial analysis of the fingerprint determines if it is a usable print having sufficient quantity or quality can now be done objectively by a machine and not by a person. Fingerprint reliability and validity, the subjectivity of the examiner, and recommendations made by SWG, which is the scientific working groups, and OSAC, Organization for Scientific Area Committees. Results need to be double checked, and the language for trials needs to be standardized. Altering or disguising fingerprints. As soon as fingerprints were discovered to be a means of identification, criminals began to devise ways to alter them so that they could avoid being identified. John Dillinger put acid on his fingertips to change the appearance, something he likely learned from stories of workers in the pineapple fields of Cuba who did not have readily visible fingerprints. This is because chemical substances found in the pineapple plant, when combined with the pressure of handling the plants, dissolved the worker's fingerprints. Fingerprints taken from Dillinger's body in the morgue were compared to known examples left behind during his life of crime. Despite his efforts to destroy his fingerprints, they still allowed him to be identified. Sometimes the scars formed by trying to remove the fingerprints make the fingerprint identification actually easier. Advances in fingerprinting. New technology has allowed for speed, accuracy, and reliability. Scanning technology and digital systems of identifying patterns, even the ability to pick up trace amounts of DNA. Fingerprinting is as much part of the future of forensics as it has been part of the past. New technology has significantly improved the speed, accuracy, and reliability of fingerprint analysis. In an attempt to reduce the subjective human errors made in preliminary fingerprint screenings, scientists at Michigan State University have developed an algorithm that automates the standardization as the key step in fingerprint analysis. Large databases must be used to help refine machine learning process. With new scanning technologies and digital systems of identifying patterns, fingerprints can be scanned at resolutions of 500 to 1,000 dots per inch. This provides an image that reveals minute pore patterns on the fingerprint ridges and allows for more precise pattern comparisons. Entirely new uses for fingerprints are being used and developed each day. Trace amounts of DNA have been recovered from fingerprints that help identify suspects at a crime scene. Technology is under development to provide molecular fingerprints from a fingerprint sample that might someday tell us much more about the lives of the fingerprint donors than just their identities. So, in summary, humans have noticed that the pattern on their hands for thousands of years. The elevated regions in the skin of the finger are called friction ridges. Secretions from sweat glands leave small amounts of oils and salts. Fingerprints found at the crime scene are latent. Fingerprint patterns are classified as loops, whorls, and arches. Minutia patterns are small distinguishing features. Criminals have sought to alter their fingerprints with chemical surgery and superficial destruction. Fingerprints must be properly collected and documented. Fingerprint collection and documentation may involve dusting with specialized powders or chemicals. And today, much of the fingerprint analysis is automated. Mobile handheld scanners obtain fingerprints of suspects. New uses of fingerprints include DNA analysis and chemical analysis. And fingerprint analysis has become less subjective, faster, and more reliable. And that is the end of chapter 6.